Hello and welcome to the next video in my pre-algebra review series. Today's video reviews Chapter 4, Section 6, entitled Rational Numbers. By the end of this video, you should have a better understanding of rational numbers and be able to identify and graph them as necessary. Plus, be better at evaluating fractions containing variables. Please leave a like if you found this video to be helpful. If you would like me to cover any aspect of this topic in greater detail, please leave a comment in the comment section of the video. Thank you. Before we get going, I'd like to go over a definition of a rational number. A rational number is a number you can write as a quotient, such as a over b, and that's of any two integers. But b is not 0, because you can't divide by 0. All integers are rational numbers. This is true because you can write any integer as a, for instance, as a over 1. Included in rational numbers are whole numbers, 0, 75, 3 divided by 3, 288, whatever. It doesn't matter the number. Whole numbers are rational numbers. Integers, including all your negative numbers, negative 1, negative 130, negative 12 over 6, negative 7 divided by 1. These are all integers and they're all rational numbers. Also for the rational numbers are 6/7 minus 3/4, 21.84444 forever, minus 7 over 2, 0.25, minus 4 7/8. Those are all rational numbers. Additionally, you should be aware of the following for negative numbers. There are 3 ways you can write a negative number, a negative rational number. And that is with the negative sign out here in front of the fraction, like over in here. Or you could have the numerator with the negative sign. You could say negative 7 divided by 9, or you could say 7 divided by negative 9. All 3 are legal ways of defining a negative number. But the moment you have a negative sign on the top and the bottom, it becomes positive, because a negative divided by a negative is a positive. And also you should be aware that for any rational number, there is an unlimited number of equivalent fractions. So any one fraction you can come up with, we could make an unlimited number of fractions that are the same, that have different proportions, but represent the same number. Example 1, write equivalent fractions. It says write 2 lists of fractions equivalent to 1/2. Well, the work's already been done for you, but we'll go over it anyways here. So 1/2 is equal to 2/4, 3/6. The relationships stay the same. This goes on and on forever. They all equal to 1/2. Also, 1/2 is equal to minus 1 over minus 2, because a negative divided by a negative is a positive. So it's negative 1 divided by negative 2 is 1/2. Same thing with negative 2 divided by negative 4 is 1/2. Note that dividing one negative number by another negative number results in a positive number. Each fraction above is equivalent to 1/2. In situations where only one of the numbers, only the numerator or the denominator, is negative, the fraction is then negative. Example 1 of check your understanding. It says write 3 fractions equivalent to the numbers. So we'll look at A, B, C, and D, and we'll see what we can come up with. Well, for A, we're going to keep these simple. So we're not going to get real carried away with the numbers we're using. But we can write 1/3 as, we can multiply the numerator and denominator by 2, and then we could end up with 2/6. Or we could also 1/3 times 3 on the numerator, so it'd be 3/9. These are equivalent. How about this one here? 4, we're going to multiply 4/5 by the 2 on the numerator and the denominator. So we'll have 8 tenths. But this is negative, so how do we want to write that? We can write it, so this is equal to, we can write the negative out in front, we could write the negative here. Let's write the negative here. Negative 8 divided by 10 is equal to negative 4/5. Also, we could write, let's multiply this by 3, so we can have 12 divided by 15. 3 times 4 is 12, 3 times 5 is 15. And we want negative, so we could put the negative down here with a 15. 12 or negative 15, same answer. How about one more? We can do one more of these. We can do, what do we do? 2, 3, let's do 4. So 4 times 4 is 16 over 5 times 4 is 20. And in this case, we want negative, so we can put the negative out in front if we want. Still, same thing. Over here, I realized we missed one, so we do 3, we do a 4. So it's 4 over what? 12. And this is a positive number. These are all equal. Okay, let's go on to 5/8. So let's try something a little different this time. We're going to do 5/8. Let's write it differently. So it's times 2. So 5/8 times 2 over 2 is equal to 10 over 16. Okay? But we want positive, but I'm going to put negative here and negative there. So negative 10 divided by negative 16 is 5/8. Another one we could probably do is 3. So 15 over 24. That's another equivalent. And we could do 5. 5 times 5 is 25 over 5 times 8 is 40. And guess what? We can do the same thing we did before. We can make them both negative, top and bottom, because a negative divided by a negative is a positive. And how about the very last one? We have negative 1/2. So we could say that this, let's do times 2. So 1 times 2 is 2, and 2 times 2 is 4, and it's negative, so we'll just pick any one of these to be negative. We could do 3 times 3 over 6 and make the bottom negative, or we could do 5 over 10, 5 over 10, and have the whole fraction negative out here. So negative 5/10, all equivalent. So in example 2, check your understanding. They're looking for us to graph each of these numbers on this number line that's provided for us. And it appears that the number line should probably be designated as 1, negative 1, negative 2, negative 3, okay, negative 4. And the reason why is because I'm skipping every other one because we have small numbers to put in here. And then this one up here would be 1. This is 0. So the very first one, A, is negative 1/2. Negative 1/2. So if this is 0 and this is negative 1, this right here is negative 1/2. Negative 1/2. If we go to B, negative 4/10. Well, 4/10 is just a little under 0.5, so, and it's negative, so it's going to be right in here. It's going to be in the same spot. It's going to be right 4. This is 10/10. 4/10 is going to be right here. Negative 4/10. The next one here is minus 2 or negative 2. Right here is negative 2. We're going to draw it right here. And it is negative 2. Negative 2 right there. And this is 0.9. Well, if 1 is out here and 0.5 is here, 0.9 has to be right up in here. Almost to the 1 point. So this is 0.9 graphed. For objective 2, evaluating fractions containing variables, we're going to start off by talking about the definition of a fraction and the contents above and below the fraction bar. Recall that a fraction bar is a grouping symbol, as are parentheses, braces, and square brackets. First, you must simplify the numerator and the denominator, and then you can simplify the fraction in its entirety. Everything above the fraction line is to be treated as a single number, as the same goes for the denominator. Everything below that fraction bar must be treated as a single number. So in this example here, simplify the numerator. 1 plus 9 plus 2 over 2 minus 5. That equals 12 divided by minus 3. Because it's 1 plus 9 is 10, plus 2 is 12, and 2 minus 5 is minus 3, or negative 3. The final answer then is 12 divided by negative 3, which is negative 4. Here in example 3, real world problem. The speed of a car changes from 37 feet per second to 102 feet per second in 5 seconds. What is its acceleration in feet per second per second? As you see, feet over seconds squared. Well, we're going to use the formula. A is equal to F minus I over T, where A is the acceleration, F is the final speed, I is the initial speed, and T is the time of acceleration. So if we put the formula together, we see it right here, where we have the A, the acceleration, is equal to 102, that's the final speed, feet per second, minus 37, right here, the 37 is the beginning speed, and it's over 5 seconds. So when we reduce this down, we take the top, and 102 minus 37 is 65 feet per second. The units must stay with the numbers. In fact, keeping the units with the numbers in these story problems is important, because then you, hopefully if you do the units correctly, you can help to determine if you did the problem correctly. So the final result for this is 13 feet per second squared. That's what we wanted, feet per second per second. And that's what we have here. Second squared is second per second. So now I ask a question. Can anybody explain how the second squared term came about? Because here we have 65 feet per second, and that's over 5 seconds. So where did all of a sudden the second squared come by itself here without the 5? So could you say what happened? Well, what's going on here is this is a division problem, and a division problem says that if you're going to divide with units in a denominator in the numerator and in the denominator, you can say this is 65 feet per second divided by 5 seconds. But when you can divide the numerator into the denominator into the numerator by inverting and multiplying. So what you can get then is, on the units, we're going to do that. So you can divide the 65, you'll end up with 13, and you have feet per second over seconds. That's over 1 second. So now to get rid of this second in the denominator, you multiply by the inverse, and that gives you 13 feet times 1 over, okay, I guess we're going to draw this out here like this, over seconds, because it's feet per second, and we inverted the bottom one, so it ends up being 1 over seconds. So that equals 13 feet per second squared. That's because the s seconds, they multiply together now. So I'll write that a little neater. Ends up being 13 feet per second squared. Because in order to divide this seconds out of the denominator here, you could invert it and multiply. And that's how you move this to the top. So that's basically how that happened. Okay, example 3 under check your understanding. The directions say evaluate A equals 6, B equals -5, and write it in simplest form. So we'll see what happens here. So the first one is a plus b divided by negative 3 equals, so let's write it out. Let's see. A is equal to 6. 6 plus b is negative 5, so I'm going to say negative 5 over negative 3. So what is 6 plus a negative 5? 6 plus a negative 5 is 1 over negative 3. There's your answer, minus 1/3. Let's do this one. 7, it's the same a and b. So 7 minus 5 over 3 times 6. 7 minus 5, a minus is a positive. So it's 12. And 6 times 3 is 18. And that is equal to what? Can we reduce it down? So this can be reduced. We can take about a 6 out of this. So that would end up being 2/3. Let's do this one, C. So C says 6 plus 9 over minus 5. 6 plus 9 is equal to 15 over minus 5 is equal to minus 3, because the 5 divides into the 15. And we get a 3, and the minus sign stays, so it's minus 3, negative 3.